Okay, so once you have a foreign agent, you do registration. And this is the process by which the HA is informed of the mobile node's current location and COA. So in other words, a message is passed back to the home agent saying your mobile node's over here, and here's the address at which it can be reached. So after discovering the foreign agent, the mobile node sends a registration request to the foreign agent, and the foreign agent forwards it to the home agent. That's a question?
Does that second point take place before the first one?
Oh yeah. So this is the way to parse this is, in general, this is what happens, and here is how it happens.
So when as an FA, when we have a mobile node that appears in the foreign network,
yes,
and we do retain our original IP from the home network, the one you mentioned in the previous lecture.
Yes. So
can that be used as an initial transmission between the foreign network and because it's trying to acquire the network, and you have the mobile IP, so the foreign network will realize, oh, this mobile node is not my network, the IP is different. So it tries to communicate with the home network, and that's where it gets authenticated.
I see. So you're basically saying the mobile node shows up, starts communicating with its original IP address, and the foreign network is smart enough to recognize that.
Yeah, and then an original IP address of the foreign network is assigned to the mobile node.
So my sense is that so it doesn't actually work that way, and there's probably a good reason. And the good reason is that if you just show up and start broadcasting, you've got no confidence that there actually exists a foreign agent taking care of you. So that's why all of the control messages have to be routed through your foreign agent, so that everyone is confident that there is an actual IP tunnel that's taking care of the packet forwarding.
Why would mobile node communicate with the HNA? It's going to the C end.
That's right.
Yeah.
So I mean, right now we're just talking about the control message traffic. So yeah. Okay. So the home agent will receive receives the registration request, and updates its location registry. So a couple of things to know about this registry. Firstly, just a terminology issue. Entries in the registry location bindings. And so that's, so we have two things, terminology issue is that. Second thing is a fun fact. They have expiries, they have lifetimes. Each location binding has a lifetime. And if the lifetime expires before it's been refreshed or before a new entry has been found, then that location is deleted. And that basically is there so that if you turn your device off, after a certain amount of time, the home agent knows to stop forwarding packets, because there's no point in doing that anymore. So the message traffic in registration will look something like this. Assuming we're using agent advertisement, this will be figure 2. So assume you've seen diagrams like this before. This line will represent the mobile node. This line will represent the foreign agent. And this line will represent the home agent. So right here, we'll say mobile node arrives. And let's ignore the amount of time required for the mobile node to set up its IP address. In fact, let's say that at arrival it will have a local IP address that it can use, and at that point the foreign agent should detect that condition, and let's say immediately it sends an agent advertisement. Okay, so this is time in these kinds of graphs. Can anyone tell me what's the interpretation of this span here? The latency between that message being sent and that message being received. The propagation delay, exactly. So once the mobile node receives that, the mobile node sends registration request. And the foreign agent will then forward that registration request to the home agent. The home agent will update its location binding and will send an acknowledgement or a response. Which is finally forwarded to the mobile node, and once that happens, we're all set up and ready to go. So that setup took this amount of time. This is the time required for link setup. Or to set up forwarding, let's say. Okay, so that's interesting because what's going on here? The mobile node arrives here, which means that over here, the mobile node was a member of a different network. And until we get to here, nobody knows where this nobody knows where this node is. That link has not been set up. So for that reason, actually, excuse me, that's not true. Once the home agent knows that, once the home agent knows where you are, at that point, packets can be forwarded to you. In fact, this is the time required. This is the time required for link setup, and this is the time. This is kind of the dead time over here. I'll call that the dead time because that's the amount of time during which packets will be dropped. If a packet is destined for you, chances are, in this time, either the home agent doesn't know where to forward it, or it got forwarded to the wrong place.